All right, now I'm looking at question C. The key word here is exothermic. Exothermic reactions make heat, and heat can only be produced if the potential energy of the atoms decreases. So if we go back to the diagram up here, if you started at B and you dropped in potential energy going to A lot of heat would be produced. 2,640 kilojoules per mole would be produced going from B to A. If you went from B to C, even more heat would be produced. This would be 3,440 kilojoules per mole if you went from B to C. But question C is not starting at the unbonded state. Question C is saying, let's start at arrangement A here, and let's end up at arrangement C over here as products. So from A to C, which is this one right here. Okay, so now I'm going to try to represent the energy of state A. I can't use this number directly, this 2,640. I have to make it a negative. Let me write in the margin. Negative 2640 kJs per mole is the starting place. And the ending place, go back to the diagram, is low. It's very low. So I write that as a negative number to show it's very low. So that's the beginning and end here. So if I do that well on my graph, I'll start here at negative 2640 kJs per mole. And I'll end at negative 3440 kJs per mole. And if you understand how to do the profile, there's the starting state, and it drops, and here's the ending state. So that is the potential energy change. They're both low in potential energy compared to the unbonded state. But this arrangement right here, arrangement C, is much lower in energy, much lower in potential energy than arrangement A. Arrangement A has weaker bonds. Arrangement C has stronger bonds. Okay. That's the energy profile. We can express the change using the symbol delta, which looks like a triangle. And we can put a letter H here and express the difference as 800 kilojoules per mole. Notice I wrote a negative sign because it's downhill. That expresses the fact that this is exothermic, and this tells you the amount of heat produced, which you can see is relevant. When we get to D, how much heat is produced? Boom, there it is, 800 kilojoules of heat for each mole of CH4 that reacts! Exclamation point.